Okay, we are here with section 6.2, looking at the right triangle approach for trigonometric functions. So we'll look at the trigonometric ratios, the special triangles, and the applications of trigonometry and the right triangles. And we've already reviewed this a little bit, so we'll look at sine is the opposite over hypotenuse. So what we're talking about is when you are concentrating on this angle here in the triangle below theta. If I am saying opposite, I am saying that it would be opposite this angle. And then this is the hypotenuse. Or if I'm looking at cosine, I'm looking at adjacent of the angle, which would be this side. Okay, so this is when theta would be this angle. Now, if theta is the angle up here, then you go opposite and adjacent this way. So you have to pay attention to what angle that you're talking about. So here we have opposite over hypotenuse, adjacent over hypotenuse. Tangent is opposite over adjacent. Obviously, if you divide the sine and the cosine ratios, the hypotenuse will reduce and leave you with opposite over adjacent. Then the reciprocals of these functions below would just be the flip of sine. Cosecant is hypotenuse over opposite, secant is hypotenuse over adjacent, and cotangent is adjacent over opposite. So the symbols that we do use are the abbreviations of the full name: sine, cosine, tangent, cosecant, secant, and tangent. And since any two right triangles with an angle theta are similar, these ratios are the same regardless of the size of the triangle. The trigonometric ratios depend only on the angle theta. So depending on how big that angle theta is, will depend upon the ratios. Find the 6 trigonometric ratios of the angle theta in figure 3. So here we have theta being this angle below. You always want to make sure that you definitely have a right triangle. You don't want to be tricked by not having a right triangle and then using something that will not work for a regular or a triangle that is not a right triangle. I won't call it regular. We'll say triangle that's not a right triangle. So here we have sine, which is our opposite over hypotenuse, cosine, which is our adjacent over hypotenuse, and then our tangent, of course, is opposite over adjacent. The reciprocals of these, you just flip them all over. Now you probably will have to rationalize in this example the tangent and the secant at times, but this is just for the purposes of showing you the relationship between the sine, cosine, and tangent and their reciprocals. Now we'll take a look at special right triangles. So the first special right triangle is our 45-45-90 triangle, and we again are going to use the legs of this right triangle as 1 as a simple example to show the relationship between those and the sides. So how did I do that? Well, you know Pythagorean theorem is going to be your a squared plus b squared equals our c squared. So if we know that the legs are 1, we're going to have 1 squared, which is 1, plus 1 squared, which is 1, and then we're solving for, oh, I forgot to put the squared up here, c squared. So I'm going to add those two together, obviously get 2, take the square root of both sides, and that's how I know that my relationship is the square root of 2. Now how do I know it's positive? Because I'm looking at distance, so I'm going to use the positive. In this case, we might use a directional -2 for something else, but when we're talking about just the distance of the side, we will use the positive. By the Pythagorean theorem, we have a diagonal that has this length of the square root of 2, as we just shown, on the 45, 45, 90 triangle. And, or you could say pi over 4, and pi over 2, if you're looking at the radian measurement. To get the second triangle, we start with an equilateral triangle. Equilateral triangle, remember, has equal angles of 60, 60, and 60 all the way across here. So if we bisect the equal angular triangle straight down and make this a right triangle here, then we're creating a 30, 60, 90 triangle. Now, if we start with this side of the length of 2, we will find that this side across from 30, and that's what is key here to remember, across from 30 degrees is 1. The hypotenuse then would be double that. And then by the Pythagorean theorem, where we have our a squared plus b squared equals c squared again, if I plug in what I have, which is 1 squared, I don't know my b squared yet, and my hypotenuse is always c, so that will be 4, which is 2 squared. This will be 1. When I subtract it, I will have b squared equals 3. After I subtract my 1 from both sides, take the square root, and then of course, since I'm looking at distance, I'm going to use the positive, which is the square root of 3. So that's how I get my square root of 3 here. Now, any multiples of these, so that's why when we look at the generic, we usually call this x. We call this 2x. And then we call the side opposite of 60 the square root of 3x. And we do the same with the 45, 45, 90. My legs that are 1 are both x, and then my hypotenuse is the square root of 2 times x. Okay, so this slide again is just emphasizing that we have dB being the square root of 3. Since it bisects angle ABC, we obtain the 30, 60, 90, which is in radians, pi over 6, pi over 3, and pi over 2. And now we can use these special triangles to calculate the trig ratios for the angles with these measures of 30, 45, and 60. So this is another way that we can take a look at finding the values. Another way, other than the unit circle, we can use these special right triangles. So there we have them in radians, and we could have put the pi over 2 on here as well for our 90 degrees. And we have our radians of pi over 6, pi over 4, and pi over 3. We're going to take the sine of these values, then the cosine, and then once we get sine and cosine, we can figure out our tangent, cosecant, secant, and cotangent again. Now, the math models used in finding the trig ratios are programmed directly into the scientific calculator, so you can get your values of sine, cosine, and tangent, and other ratios can be calculated from them. Again, as we said, the reciprocal of sine is cosecant, the reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. So when we follow the convention, we write sine of t, which means the sine of the angle whose radian measure is t. For instance, sine of 1 means the sine of the angles whose radian measure is 1. When using the scientific calculator for this, you'll get an approximate value. Now you need to make sure that your calculator is set on radian mode. Very important. You need to pay attention to whether you're dealing with your radians. Sine of 1 as a radian is this, but sine of 1 degree is completely different measurement. So you need to focus on whether or not it is a 1 degree or a radian measure of 1. Let's look at a few applications. Triangle has 6 parts, 3 angles, 3 sides. So if we want to solve a triangle to determine all the parts from the information, that means to determine the lengths and the measures of the 3 angles. Here we have a triangle that is a 30, 60, 90. How do I know that? Because this side is 30, it's a right triangle, so this side must be 60. So let's take a look at finding the side measures. So if I solve for A, I know that A is 12 sine of 30, and that would be 12 times 1/2, which is 6. So again, we know sine of 30 degrees is equal to A divided by 12. How do I know that? Because sine, again, is opposite over hypotenuse. So let's take a look. If this is 30, opposite is A, over my hypotenuse is 12. So that's the equation, sine of 30 degrees equals A over 12. Then you solve for A by multiplying both sides by 12, and you can get A equals 6. Similarly, you could do the cosine of 30 to solve for B. You could also use the Pythagorean theorem to solve for B. And here we have B equaling 6 square roots of 3. So now we need to take a look at a little bit of terminology for where we apply this. If we have an observer looking at an object, then the line from the eye of the observer is called the line of sight. Makes sense, right? If it's coming from the line of sight, it comes from the eye. So if I am looking up from my eye, I have an angle of elevation. If I am looking downward from my eye, I have an angle of depression. My line of sight is to the point that I am looking at. And then you want to have your horizontal line from your eye straight to the object that is in line with where you are looking. You want to have a horizontal line. Slope of 0. I will say slope of 0 from your line of sight. If the object, again, is above the horizontal, we call it the angle of elevation. If it is below the horizontal, it's the angle of depression. The line of sight follows a physical object such as an inclined plane or hillside. We use the term angle of inclination. So again, if the line of sight follows a physical object such as an inclined plane or hillside, we're going to call it the angle of inclination. So we have a giant redwood tree casting a shadow of 532 feet long. We want to find the height of the tree if the angle of elevation of the sun is at 25.7 degrees. So we have degrees here in this example. So here's what it would look like. It's always good to draw your picture. We're looking at the sun. The angle of the sun to hitting the ground, the angle of elevation, then would be 25.7. We want to find out what the height of the tree is. We know that the shadow is 532 feet. So we want to look at our opposite over adjacent, which would be our tangent. So we're looking for the tangent of 25.7 degrees is our opposite, which we don't know, our height, over our adjacent, which is 532. Solve for this. And we'll use calculator here. So it's approximately 256 feet tall would be the height of the tree. Okay, well that is all for section 6.2. The one thing that we didn't talk about in the beginning of this section is the acronym SOHCAHTOA. I think we've looked at it before, but it might help. So it's SOH, and we used to we would tell a story of a Native American girl with the name of SOHCAHTOA, and now I don't know if they're just taking that out because we're being very sensitive about how people feel about their ethnicities being brought into examples. So anyway, if you can remember the acronym SOHCAHTOA, it will help you remember your ratios. So we have our sine is opposite over hypotenuse. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. And tangent, opposite over adjacent. And that's all I have for you for today. Thank you.